All right, so today we're going to take a look at radical notation and rational exponents. Okay, so we're used to seeing radicals where we have something like the nth root of b to a power. Okay, that is the same thing as having b to a fractional exponent, where that fractional exponent has n, the index, in the denominator, and m, the exponent inside, as the numerator. Okay. So if I had something like the cube root of x, I can write that with a fractional exponent instead. The base is still an x, the index is a 3, the exponent here is a 1. So this is x to the 1/3 power. So what I want you to do is copy down these problems and go through and try to write them in the opposite notation. All right, so for the first one, this is 53 to the 1st power. This is a square root. So this is 53 to the 1/2 power. And that's it. The second one already has a fraction exponent, so the question is, how do I write it as a radical? Well, the denominator is the index, the base is an x, and the numerator is the exponent. Let's try the other two. This is going to be y to the 5/8 power, because the power is a 5 and the index is an 8, and the index is always the denominator. And then for this last one, we can write this as a radical. The denominator is the index, which means inside I have 15 squared. Now when it says to just write it in the opposite notation, you can go ahead and stop at that point. You can, if you would like, figure out what 15 squared is to simplify the inside. That is optional, that is not mandatory. Okay, so that's an option, not a requirement. So that's converting from radical notation to rational exponents.